Alright, so as we discussed in the last lesson, a pointer is a variable that contains a memory address. You can think of pointer as the data type for memory addresses in general. When a pointer contains the memory address of a variable, it is said to point to the variable located at that address. Let's suppose we want to create a pointer that will point to an unsigned short int. In other words, we want to create a variable, the pointer, of data type memory address, and we want that variable to contain the memory address of an unsigned short int. To do this, you would write unsigned short int some pointer. Now, as you can recall from the last lesson, this part that I've highlighted says that we're creating a pointer called some pointer. The asterisk means that it's a pointer. And this part tells what kind of variable we expect to exist at the memory address that it's pointing to. So when we've created this variable called some pointer, think of this as having the data type memory address. That is to say that this particular variable is going to contain a memory address. So this creates a pointer called some pointer, and we have stated that we will be using this pointer to hold a memory address for a variable of type unsigned short int. Keep in mind that a single pointer can only hold one memory address at a time. Right now, of course, this pointer effectively has no value because this pointer has not been given a memory address yet. So because this pointer is designed to hold the memory address of an unsigned short int, then it should be obvious that we cannot use this pointer until we give it a value. That value needs to be the memory address of an unsigned short int. In order to make this possible, let's create a couple of unsigned short int variables, like this. Let's say unsigned short int height equals 5, unsigned short int width equals 10, and then underneath here I'll create my pointer, short int my pointer. Okay, so notice what we've done here. We've created two variables of data type unsigned short int, and then we created one variable of data type memory address. Notice that I did not assign a value to the variable my pointer. What you should understand at this stage is that my pointer is a variable designed to hold the memory address of any unsigned short int. We have not given it a value yet. Remember that a pointer is useless if it does not contain a memory address. Let's suppose that we want to give the pointer, my pointer, the value of the memory address for the variable width in our above example. This means that we need to have some way that we can write this line of code. My pointer is equal to the address of width. Now think about this line of code. If we could write this, then what we're basically doing is we are storing inside of the variable my pointer the memory address of the variable width. This is not actual code, but it describes what we need to do. Now let's simplify this a bit. Rather than typing the words address of let's use a character on the keyboard to mean this exact same thing. Let's choose the ampersand character. In other words, let's just say that the ampersand character means address of, so that we can write this line of code simpler by writing my pointer equals ampersand with, where the ampersand simply means address of. Believe it or not, that's exactly how you do it. In C, the ampersand character literally means the address of. Anytime you want to set a pointer to the address of some variable, you simply do it like this. Notice that both of the below lines are exactly the same. If I write pointer equals ampersand variable like that, or if I write pointer equals ampersand variable like that, or if I write pointer equals and variable, same thing. These are all the exact same lines of code. The spacing is purely a matter of preference. In all of these cases, we've done the same thing, which is what we've done is to say that pointer is equal to the memory address of the variable. So let me just write this out one more time. If I write this, the variable pointer now contains the memory address of variable. Remember that the ampersand character just means the memory address of. Now, why do we want to do this? Because now we can look at that memory address and obtain the value located at that memory address. Now, I can imagine you saying, sure, but we can do that anyways without pointers. Yes, you can, but only for single variables of a given data type. And that is not how real code works. In a real program, you must be able to process large data structures, not simply an integer or a character. A large data structure could be music or graphics or something else. There is no data type built into C or any programming language for something so complex. Therefore, the way to process a large data structure is to set a pointer to the start of that data in memory, and then you process it by moving the pointer through the data as you perform operations on the data, like for example playing it to your speakers. So what you need to know from this lesson is that the ampersand character means address of, and when you create a pointer and you want to assign that pointer the memory address of some variable, you do it like that. We're going to go over this in more detail later on, but as long as you can remember this, then you are fine. If you have any questions, feel free to ask.